Morning, everybody. Today I want to talk to you a little bit about Newton's second law for circular motion. So there's a law, it goes along with Newton's second law of motion, which basically addresses the equation F equals m times a. So this law states that Newton's second law for circular motion states that the centripetal force on an object moving at a circle is equal to the object's mass times the centripetal acceleration. So instead of talking about an object accelerating along a linear path, now we're talking about an object that's accelerating along a circular path. So the formula is slightly different. I don't know if you can see this down here or how well you can see it. F equals m times a. That's what we introduced before back first semester in chapter 4. This formula here is the net force equal to the mass times centripetal acceleration. It's a pretty similar formula. F sub net equals m times a sub c. So all these problems here, you might remember a sub c, centripetal acceleration. I did a video on that here in the last couple days. We're going to, with these problems, it's basically a two-step process. Number one, figure out centripetal acceleration, just like we did before. And then number two is take that extra step and figure out what the net force is by applying this formula here. So centripetal acceleration, again, is the speed squared divided by the radius. Remember, the radius is just talking about the distance from center of the circle to however far out from the center of the circle it is we're talking about. Excuse me. In this particular example here, we're talking about the speed of 1.2 revolutions per second. All right, it's just the speed divided by the radius. Notice that the speed is squared. All right, so 1.2 squared divided by the radius provided as 0.93. And excuse me, when we do that, we get 1.55 meters per second squared. Now, what we want to do then is take that extra step, because we figured out this is just centripetal acceleration. So you're not finished when you get to this point, because all you figured out was centripetal acceleration. The final step, the second and final step, is to go ahead and multiply the centripetal acceleration by the mass that's provided. So in this case, we're going to take 17 times 1.55, and we're going to get 26.35 newtons. And that basically answers the question, how much force is exerted by the string on the object. So in this case, we might be, like I said, we're twirling something above our head, kind of like so. So we're trying to figure out how much force is exerted by the string on the object, and that's what this question is answering. All these problems are done the exact same way, two-step process. Again, figure out centripetal acceleration first, and again, you saw this formula on a previous video, and then go ahead and multiply that by the mass by using Newton's second law for that equation for Newton's second law for circular motion. And be sure to answer the question about the relationship between centripetal acceleration and the net force that is exerted by the string on the object. Don't leave it blank. You'll see a pattern as you work your way through this worksheet. Think your way through it, and you should be in good shape. As always, if you have questions, let me know. I'm more than happy to give you a hand.